Good morning. I'm Tad, and I'm here with my friend Jeffrey. And if you're here for the PowerShell presentation, that's not what this is about. It's a little confusing, perhaps. But Jeffrey and I are members of the Azure Storage, Media, and Edge team. And this morning we're going to be talking about Azure Storage. So we'll walk through in some detail some of the announcements recently, some of the announcements that have been made at the show. We'll talk about where we're headed for Azure Storage in terms of our long-term vision. Then we'll dig into some customer use cases and some workloads. We'll have lots of demos, and I hope by the end of this you'll appreciate that Azure Storage is the most comprehensive and capable cloud storage platform in the industry today. So quick overview of what is Azure Storage. Azure Storage includes the disks capability that we have to support IaaS virtual machines. Comes in a couple of flavors, premium, standard. We have object storage, which is our scale-out storage implementation or service. We call that Azure Blobs. It's for unstructured data sets. And then we have file storage services as well. We have Azure Files, and then Azure NetApp Files with our partnership with NetApp also. And those are for applications that are traditional enterprise applications or even next-gen cloud applications that start to take advantage of scale-out file systems in the cloud. We have edge products that enable you to move data in and out of the cloud. We have data transport features, and we have hybrid storage features as well to synchronize data and burst compute data from on-prem into the public cloud platform that is Azure. So let's talk a little bit about as you're moving or as a customer is moving over to a hyperscale public cloud platform like Azure, let's talk about what are the storage requirements that are just intrinsic to that kind of a scenario. So first of all, with respect to a cloud storage platform, you need the fundamentals. You need to have consistent and straightforward guarantees having to do with durability, security, and scale. Those are just fundamentals of a hyperscale storage platform. You need the ability to have different performance tiers with different price points. You have workloads that may, for a period of time, need to run on a hot SSD tier, let's say. Then over time, they can sort of tier down into a less expensive archive tier, for instance. So you need to be able to support all of those price and performance tiers. You need to be able to get to your data through a variety of protocols. You don't want to have this siloed approach where, based on the type of application that you have and the protocol that it uses to access its data, you get boxed into a particular storage service with different fundamentals, let's say. You want to be able to have consistency with respect to whatever protocol you're using for your application across the different tiers of storage, as well as with respect to the fundamentals. And you want to be able to support all of the necessary workloads, especially for enterprises, to be able to deploy existing as well as cloud-first solutions in the cloud. And then with storage, we talk a lot about these days, and at the show in particular, we talk a lot about intelligent edge. So there's intelligent cloud and intelligent edge. The edge and storage, they go very well together, and that's why we have as our team, the Storage, Media, and Edge team, that's why we're all one team, because it's just and I think you'll find this over time, that as the edge capabilities improve, more and more storage will be the anchor point across the edge and the public cloud. So you need to be able to get data into the cloud, out of the cloud, smaller data sets in the terabyte size, large data sets as well. You need to be able to have APIs that are the same APIs whether or not you're in the public cloud or in your own private cloud on-prem at the edge. And you need to be able to extend your data center into the public cloud so that it's seamless, so that it's not this, again, this siloed security and networking experience with respect to edge and the public cloud. And then, of course, you need a rich partner ecosystem who's building on top of this Azure storage and edge, the storage and edge platform. So let's talk about those concepts, that sort of conceptual set of requirements in the context of Azure storage, where we are today. And we'll highlight some of the announcements that have been made in the last few months. Those areas are in blue. So we have, in fact, as Azure Storage, a design point from the very beginning of Azure Storage was that we wanted to have a single implementation for storage, whether it be for disks, for files, or for objects. And what that does for our customers, it gives you that consistent durability, security, availability. All the fundamentals are the same with respect to whatever access point that you choose to use. For instance, one thing that may not be very well known is that for each write, we write through to 3 replicas with strong consistency before we reply back. That is something that is unique, fundamentally unique in the industry, and we do that for disks all the way through file storage. We have objects, disks, files, as we talked about earlier, and we've implemented those capabilities across a range of temperatures. The blue here, our archive tier, that's a sealed tape device implementation. It's very sophisticated technology that our team had been working on for years that gives you the ability to keep your data around for long periods of time at less than half the price of our next competitor in this space for their cold storage tier. We have Azure Databox Disk, Azure Databox, and Azure Databox. We have the Disk product here. We have the Databox product here if you want to come up afterwards and take a look. It's also on the Show Expo floor. We have Azure Stack in a whole suite, a whole spectrum of edge offerings to give you our APIs at the edge. You can integrate your DC, your environment with our hyperscale public cloud using backup, using Azure Site Recovery or ASR. And then we do have a very rich hundreds and hundreds of partners who have built on top of our platform for all sorts of scenarios, backup, DR, archiving, as well as vertical or industry-specific scenarios. So let's talk about some of the recent announcements. And these are things that have been announced in the last 4 or 5 months or so. ADLS Gen 2, Azure Data Lake Storage Gen 2, and Jeffrey will get into this in more detail. But what it does is it brings the full power of a structured file system deep into the scale-out or object storage implementation or service. This is the first in the industry of being able to bring file system semantics natively integrated into the server side of the cloud storage system. There are HDFS, which is the primary endpoint for ADLS Gen 2. There are HDFS implementations in the industry that are client-side, so they don't have that ACL support in the same way that we have in our platform. And so this is very exciting for us, ADLS Gen 2. We have Avere. Avere came to us through an acquisition of a company in Pittsburgh earlier this calendar year. A couple of ex-CMU professors founded this company where they've enabled a cache so that you can have very hot access to your data for high-performance computing for very scale-out compute scenarios. We have support now for premium blobs announced at the show, the absolute fastest object storage implementation on the planet. We have Ultra SSD, also announced at the show, the absolute fastest disks implementation on the planet, and premium files as well. So what you're seeing here, I hope this picture, again, this picture of the most comprehensive platform for storage is starting to show up, where we have the least cost cold or archive storage tier, and we have the fastest, best performance on the planet as well for disks, objects, and then support for premium files as well. So let's dig into some of these areas in a bit more detail. Avere, the beauty of Avere is what they had developed is this file system cache that sits in front of your primary storage. And when Avere was originally developed, it was designed as one of the first all-flash storage implementations, hardware-based, that would sit in front of an ONTAP device or an Isilon device and accelerate high-performance compute workloads against that primary data store. So then over time, what happened is the Avere team, they pivoted over to supporting hybrid cloud scenarios as well. So you can take this Avere cache and you can run it as virtual machines in the cloud, and then you can leave your data on-prem on an Isilon or on TAP or some other file system on-prem, and you can burst the compute into the public cloud. So what it does is for scenarios like media rendering scenarios or other scientific computing scenarios where you may want to spin up tens of thousands of VMs simultaneously, but then leave your data on-prem. That's what you can do with Avere. So we support with Avere the on-prem scenario. We also support this hybrid burst compute scenario, and then we support the ability on top of object storage or blobs, sort of a thing you can have as your primary storage. You can have object storage or blobs, and then you can have this cache that runs on top. So it's pretty neat stuff. And at the show, we have announced that our GA date is October 31st. This is an example of one of the use cases for Avere. In the media and entertainment industry, they have requirements when they're rendering an animated feature or the visual effects for pretty much every TV show, movie that's created. There are visual effects these days, and those visual effects are rendered using very, very large scale compute. So what happens is you have all of your artifacts for rendering in your primary storage, and then you have this very scale-out rendering system that will render a few frames at a time in batch form, and then it kind of moves on to the next systems. And so what Avere does, because the working set is in common across the different virtual machines that are executing, it's very good for this kind of scenario, and it's the M&E industry where Avere essential ingredient for media and entertainment rendering scenarios are used for virtually every production on TV and the film that you see. Some aspects of that production is likely rendered using Avere. Customers, Mr. X is customers. Mr. X is a post-production studio long time, and the majority of what you view on the internet or in theaters has been touched by Technicolor in some way. And so they're one of our customers of Avere, and they're one of the customers that's doing some interesting work today with us on the Azure platform as we're in preview. Ultra SSD was announced earlier at the show. Again, Ultra SSD is the fastest disks implementation in the industry today. We can enable up to 160,000 IOPS for a single disk. So there's nothing that can touch it today in the industry. This is a capability that gives you the confidence that you can host every single enterprise class mission critical workload. You can run those existing workloads in the public cloud with no issues. In fact, you're probably going to get better performance than you would with your on-prem SAN implementation. So what I'll do now is I'll invite Wissam to come up, and he's going to talk about Ultra SSD and show you a demo.
Good morning. I'm very excited to be here to show you the capabilities of Ultra SSD. We designed Ultra SSD to allow you to make it easier for you to lift and shift your applications from on-prem to Azure, whether it's SAP HANA, Oracle, or NoSQL databases. We want you to achieve the best performance on cloud, and this is what we're giving you with Ultra SSD. So let me switch my screen. First, let's touch on capacity. We give you different sizes all the way down from 4 gigabyte to 64 terabyte. What I have here is a single VM provisioned with one 64 terabyte Ultra SSD disk. You can also stripe multiple disks to achieve much higher capacity. Now, the cool thing about Ultra SSD, we allow you to configure the performance independently of the capacity. So you don't need 64 terabyte to achieve 160,000 IOPS. So I'm going to switch to another VM. This is an ES64v3 VM. It's widely available in Azure. You can deploy it in most regions. It's maxed today at 80,000 IOPS. I have a single disk here. It's a 500 gigabyte Ultra SSD disk. And I'm going to use Iometer to generate load. So I'm going to start the test. We have 4 workers doing multiple work in parallel. And I want you to pay attention to the first row and the third row. So the first row is going to show you the IOPS, and the third row is going to show you the latency. So we are hitting the limit of the virtual machine in this case at 80,000 IOPS. Now let's look at the latency. It's constant at 600 microseconds, even at 80,000 IOPS. This workload is doing 4K writes, 100% write random writes to the disk. Now, we did announce 160K support. And for this, we are introducing a new VM size that would allow you to go up to 160K. So I have a VM configured with a single disk as well. It's a 1 terabyte disk because we have a limit of 300 IOPS per gigabyte. So you need a 1 terabyte disk to hit 160,000 IOPS. And I'm going to start the test as well. It's easily achieving 160K IOPS. So if we actually decide to provision a new VM that can go higher, we can actually hit those limits as well. Now, even at 160,000 IOPS, let's take a look at the latency. We are still well below 1 millisecond.
That's great. So how big is that drive?
It's a 1 terabyte disk.
1 terabyte. So that ratio of IOPS to terabytes is phenomenal.
Yep. It's the most you can get today in the industry. The closest you can get is IOPS per gigabyte. We are at 300 IOPS per gigabyte.
That's great. The price that we charge for IOPS, is the least cost in the market as well.
That is correct. Yep.
So you can have a small disk with very affordable IOPS, best performance in the market, right?
Yep. If you need a transaction log, 4 gigabyte disk, you can get that with Ultra SSD. It allows you to go all the way up to 1,200 IOPS, basically.
That's cool.
Now, the other cool thing is we allow you to change the performance dynamically. So you don't need to shut down the VM to change the performance of the disk. You can do this with a simple CLI command. I'm using the Azure command line here. It's showing one of my disks at, you can see it here, at 50,000 IOPS and 500 megabytes per second. All is needed is to do an AZ update, and you can switch those throttles all the way up or down, depending on your workload. It takes up to 10 minutes for the backend to pick it up, but within 10 minutes, you should see that performance reflected on your backend.
That's awesome. So another thing about the pricing is it's provision pricing.
Correct.
So you get the predictability of provision pricing, but then you can dial the perf dynamically. So you get that combination of flexibility with price predictability, right?
Exactly. We also allow you to provision throughput, so you can provision IOPS, capacity, and throughput.
And throughput, awesome. So lots of dials, but also that consistent pricing.
Exactly.
Awesome.
That should be all. Thank you.
Okay, thank you. Okay, thank you, Wissam. All right, so let's dig into some of the announcements related to our intelligent edge platform and how it intersects with Azure Storage. We announced at the show Azure Data Box, the GA for Azure Data Box. This is a 100 terabyte portable appliance, less than 50 pounds, so it meets OSHA's requirements for one human being being able to carry it around. This is one class of device. We also announced preview of Azure Data Box Heavy. That's at the expo floor. That's a 1 petabyte plus option that you can sort of wheel into your data center. And then we announced Azure Data Box Edge, which is a fixed edge storage gateway plus AI, compute, FPGA. Also announced at the show. and then with that, the Azure Data Box Gateway. And then we have Azure Data Box Disk up here as well. The nice thing about all these devices is that these are Microsoft branded hardware devices. You can contact your Microsoft seller. It's very simple. Get access to these devices. All of these devices are in a model where you pay as you use. So for instance, the DataBox Edge product, you pay a few $100 a month. We send you a device, you use it, and then when you're done using it, you can send it back to us. So it's very light from a commitment standpoint in terms of the cost, and also that really fits with the notion of the cloud, where you only pay for what you consume in the cloud, and that's true for the Edge in terms of the DataBox family of products as well. And then we have Azure File Sync and Azure NetApp Files. These are also recent announcements. Azure File Sync is GA, and then Azure NetApp Files is in preview. Azure DataBox Edge, again, this device, what it gives you the ability to take this notion of cloud storage and extend it out to your Edge environment. Or another way to look at it is you can take the data, your storage platform at your Edge, and extend it into the public cloud. So what's the trend that's happening in the industry is that, of course, the capabilities of hyperscale cloud platforms are increasing exponentially, but it's also the case that just the sheer number and then the amount of data that's being created on-prem at the Edge, that's also increasing exponentially. But what isn't increasing exponentially is the capabilities of the pipe that go from the Edge to the public cloud. And so the thing that's happening is there is a realization that hyperscale public cloud platforms are the way to go and kind of where the industry is headed for IT and infrastructure. The new realization is that you also need to be able to do advanced things using cloud developer paradigm technologies like AI and microservices. You need to be able to do those things at the edge of the network in proximity to where your data is generated. IoT is one of the use cases for sure for Edge, but just this notion, this concept of there being a ton of data generated at the edge where you want to be able to compute over that data without having to funnel it all into the cloud. That's what Azure DataBox Edge enables. So you get a storage gateway, you get this device you plug it into your system on-prem, to your network on-prem, it will expose file shares, you can drop your data in, it then synchronizes over to the cloud and vice versa, so your applications get local access to data with automatic synchronization into the public cloud. You can have compute that's running on this device in the form of microservices as well as AI. Then as the data is flowing through the device and then heading to the cloud, in the cloud it can wake up through notifications and you can have code that executes there as well. So this continuum of edge through the network to public cloud, this is a huge thing that's happening in the industry right now. And DataBox Edge is out there in front of the industry and the market in that regard. DataBox Gateway is a storage gateway. It's a virtual appliance you can run in your environment. It exposes file shares, does the synchronization. And the nice thing about both DataBox Edge and DataBox Gateway is that the Azure platform takes care of the management of these systems and products for you, so you don't have to worry about it. It's not the old style traditional IT with all that variability and complexity. This is cloud style homogeneity and then pay-go economics. So it really is the cloud paradigm, but brought to the edge in your data center environments. So we get some great use cases for DataBox Edge and Gateway, that ability to move data back and forth seamlessly over the wire, whether it's a dedicated link or just over the internet through a VPN connection, let's say. The ability to run data preprocessing at the edge using Azure Functions. You can have microservices-based applications, modern applications running at the edge. And then this is the really powerful one that we're going to see more and more innovation in all kinds of scenarios that we can't even imagine today, where data sets can flow into the cloud through DataBox Edge, and then we can have AI model training happening in the cloud using the hyperscale flexible computing, elastic computing that only the cloud can offer. and then those models can come back to on-prem so that AI inference can happen on-prem. So you can think about a scenario like a autonomous driving scenario where the autonomous driving vehicle is learning and pumping data into the cloud. Well, that vehicle may be one that you're riding in that's also capturing massive amounts of data. And then, of course, you have AI in the automobile itself. You have AI at the edge, and then you'll have AI in the public cloud as those data sets flow in, so that the whole system, intelligent edge to intelligent cloud, that whole continuum becomes increasingly intelligent over time. So that's where we're headed as an industry. So I'll invite Cassie to come up, and she's going to do a demo of DataBox Edge and Gateway. Got to switch your display.
Yeah, I know.
Okay.
I'm just going to connect first. There we go. Okay. Okay. All right, good morning. Today I'm going to cover some of those key functionalities that Tad just mentioned. First, we're going to create a share, and I'm going to walk you through the storage gateway functionality on DataBox Edge and DataBox Gateway. And then we'll talk through that edge compute scenario where we'll run a machine learning module to analyze and categorize some images. So we're going to start in the Azure portal. I'm going to bring up a machine that I've already set up. So this is a machine that is sitting in our Sunnyvale office, just as your DataBox Edge would be sitting on site, but I'm managing it through the Azure portal in the cloud. So let's just add a share so you can see how simple that is. And again, this is on the local DataBox Edge device in our office.
So you're managing the local data box via the cloud.
Yep.
Nice.
So I've given it a name, and I can choose my file structure, SMB or NFS. I'm going to stick with SMB today. I can decide to make this just a local share, and this will just act like a normal file server, and it won't copy it up to Azure. In this case, I do want my data to copy up to Azure, so I'm going to leave it. I'm going to select my storage account. And now I'm going to have the option to choose which storage service to use. I can do block blob, page blob, or files. Today, I'm going to do block blob. So it's going to create a container for me, and it's going to name it the same, or I can change that name. This is nice, too. I can also decide to make this a read-only share. Again, today I need to do some writes, so I'm going to leave that unchecked. And I'm going to use an existing user, but you can create a new user here as well. So we'll just create our share. So that's going to kick off and run in the background. The nice thing about the storage gateway functionality is as you copy files into your local share, it's going to start tiering it up to Azure. Pretty straightforward. What you don't see is that behind the scenes, we're managing any retries because your network is dropping, and we're also optimizing for your network bandwidth. So if your network is really busy, we'll hold off uploading until there's a time, so we're not sucking up all of your bandwidth.
So it can work with existing applications.
Yep.
Right?
Okay, so let's look at that edge compute demo. So on my local machine here, I have some images that I'd like to have the machine learning module go and analyze. So I'm going to pull one up to take a look at. So this is a loading dock. We've got some trucks and cars on it, and I would like this to be analyzed. So I'm going to copy these guys up to a share. So I've got two shares set up, and my code knows to look at these two shares. And in this particular one, this is DBE local, and it's going to look at the input folder. So the input folder is, my code knows to ignore it from a storage gateway perspective. So it's not going to upload it to the cloud. And so it's going to go ahead and analyze these files, and then once it's done categorizing them, it's going to bring it over to my other share, which is DBE sync, to the output directory. Now the output directory, my code has said, go ahead and act as a storage gateway for this. So this is already tiering it up to the cloud. But what's nice is I have a local copy, so I can already take some actions on this. I can have an API start acting against this to act on something that it's found in the image. So for instance, let's open up this same file. And you can see now it's categorized them. It's seen a truck, and so we
That's
can say, oh, there's a truck on my loading dock. I should take an action on this.
And that's all local computation,
yeah,
right?
Yeah, so I can already start doing that at the edge before it's even gone up into the cloud.
So that helps with real-time scenarios where in real time someone may need to know that there's a truck that's pulled up or a car that's pulled up.
Yep, yeah. And so in the background, it's already started uploading to
That's
Azure.
cool.
So let's go into Storage Explorer and just take a look at this. So I'll go into my DB sync share, into the output directory. And now you can see the storage gateway functionality has copied that up there. And so now I can start training my machine learning modules to get smarter and more accurate.
That is so cool.
So this is just a little bit about DataBox Edge. We do have a session. Get the right slide here. There's a session tomorrow where we'll dig into this in more detail. So
That's great. And the nice thing about our AI platform is that a customer who might have a scenario like this, our AI platform is designed to be accessible by average developers. You don't have to be a data scientist to write an application like that.
That's right.
Is that right?
Yeah.
Okay, awesome.
Yeah.
Thank you very much.
Thanks.
All right. Okay, so wrapping up my portion here, so let's drill into Azure NetApp Files. Azure NetApp Files is a fully managed service provided by Microsoft. It's what we call a first-party service. So the thing that's unusual here is that what we're doing in partnership with NetApp is we're taking NetApp ONTAP hardware and software, and we're hosting it in our Azure data centers, and we're delivering it to you as a first-class Azure service. So again, this is all part of that picture of us being the most comprehensive platform on the planet. If you have ONTAP workloads on-prem with all of the scale, perf, support for NFS 3.0, all their rich data management features on-prem as well as hybrid, all of that stuff is now available to you in the public cloud, and you can access it in the same way that you would any other Azure service. And so it supports hybrid scenarios as well as all of your basic security capabilities are supported, RBAC, encryption, and so on. And this is a feature that's in limited preview right now. And so Li Chun is going to come up, and she's going to show you a demo of Azure NetApp Files.
Hi, everyone. My name is Li Chun. Now let me show you just how easy it would be to provision NetApp resource on Azure. So just like using any other Azure resources, you can directly provision the NetApp resource on Azure portal. Right now, the service is in limited preview, so it's only accessible through a special private portal right now. But the first thing I would do is to create a NetApp account. This is a new type of account, similar to storage account. It is meant for administrative purpose. It is scoped to a single region, but you can have multiple accounts within the same subscription. So let's pick the right resource group here. Right now, our demo is running out from a test location. Now, as the account is being quietly provisioned in the background, there's actually a lot that is happening behind the scene. The system right now is talking through a new resource provider called NetApp Resource Provider and directly into a NetApp storage array that is hosted in an Azure DC to provision a dedicated tenancy on that array specifically for this subscription. So
it's full multi-tenant ONTAP.
Yes.
Awesome.
And compared to an on-premise scenario, it probably would take a storage admin's hours or days to do the network and storage configuration before the very first resources provision.
So you can create a volume, an NetApp volume, in real time.
Almost real time.
Great.
As you will see, almost in minutes. So now, the next thing we will need to provision is something called capacity pool. It's a concept that we have to buy pre-provision storage. Right now, we only have a premium service level. We'll have more in the future. And the minimum buy is 4 terabytes to start with. The next thing we'll need to create is the actual volume. Okay, so The volume is actually a concept carved out of the pool that we just provisioned, and therefore the quota here for the volume is consuming the pre-provisioned storage size we gave to the pool. And now let's pick a virtual VNet and a subnet for it and create. So as I mentioned, the storage array is actually sitting inside a Azure DC. It's fully integrated into the Azure network, physically and software-wise. And the way we achieve this is by utilizing a virtual VNet injection feature. As a customer, you will provision a VNet. You deploy the VM that you want to mount your volume to inside that VNet, and then you carve out a subnet, delegate it to the NetApp resource provider. And by doing that, then you will have a fully secure network path to a data volume.
So you can have an Azure virtual machine connected to a volume through NFS, hosted on an ONTAP device managed by Microsoft.
Exactly.
And this is, by the way, this is a result of a very deep engineering partnership between our two companies. So again, nothing like it in the industry.
Yep, our developer literally sit with their developer to do all the development. Now here is a mount instruction UI blade for the volume. You can see the IP for mount point. This is the IP from that subnet we just delegated to NetApp. And within 3 minutes, we have gone from absolutely nothing to a NetApp volume that is ready to be mounted. So that'll be the end of the demo.
Very cool. Thank you.
Thank you.
How do I put it back? Oh.
So you can just advance to the next.
It's a video.
Yeah.
Thanks. All right, so I'm going to wrap up. I wanted to give you a sense for where we're headed as well. Some of the themes we've talked about in terms of what's already in the product today, we're already very clearly headed in this direction, but I want to give you a clear sense for it. So where we're headed, again, is this most comprehensive but most unified cloud platform on the planet. We are going to be taking the ADLS Gen 2 file namespace and implementing a single universal namespace for all storage types. So that's something that's on our roadmap today. And then you're going to be able to access your data, again, through what we call multimodal access, through any protocol you choose. Today, even, you can go in through object storage or blobs and access through HDFS, through those file system semantics using ADLS Gen 2. We're adding, over time, NFS to that, SMB support, and so on, that unified protocol access layer. And then taking the Avere cache service, having that cover all tiers as well. We have these existing tiers for storage today, and then we're adding even more tiers across all of these different tiers, across all of these different tiers, across all of these different protocols, same fundamentals, same namespace underneath. And then you can use policy automatically, policy-based lifecycle management, or through API calls. You can have data move up and down these tiers. So you don't need to go drop your data into an archive tier and then copy it over, and then there are different APIs involved. It's all automatic. You can late bind your performance tier. You can late bind your protocol. This is where we're headed pretty rapidly in Azure Storage. So please, if you would, take a look at this URL. And go check it out. There's a lot of additional information there. And then we have other sessions here we'd encourage you to attend. There's one on Ultra SSD that was embargoed that's up there. What was the other one that was embargoed? Which one? Azure Data Lake. Is that right? No. Azure Compute and Storage. Oh, yeah, bringing Azure Storage and Compute to the edge. So please check that one out as well. Thank you very much. Now I'll bring up Jeffrey, and he'll wrap things up. Thanks, man.
All right. Hey, hello. I'm Jeffrey Snover. Boy, we've got an amazing amount of stuff to do here.
What?
Honestly, if I'm just telling you to be frank with you, I got way too much content. Way too much content. I want to lay the blame at this squarely where it belongs, and that is the Azure Storage team. If that high-class team wasn't producing innovation at this level of rate, these amazing features, these incredible things that we need to talk about, I wouldn't have the problem I have. It's a pretty good problem to have. So, 3 things. Number 1 is some of these slides I'm going to zoom through, but that's not a problem. because each of the things I'm going to talk to you about today, we've got deep drill down sessions, and we'll be showing you those. I will, at the end of each section, I'll have a slide that says additional sessions where you can go find out lots of detail. We have lots of great personnel at the booth. Go talk to them, follow-up questions. I'm going to optimize for the demos. So some of these I'm going to go through pretty quickly, okay? So let's talk about this. Your business runs on data. Your business runs on data. There are 4 types of scenarios that you have, and you need to optimize for these scenarios to really, protect and advance your company's business. The first is information workers. Now, we're not going to talk too much about that because really the best solution for that stuff is OneDrive. OneDrive offers fantastic capabilities, and there's a number of sessions that will talk about the fantastic capabilities of OneDrive. Key thing to note here, OneDrive layered on top of Azure Storage. Hoorah. Number 2, applications for data. This is where the bulk of things have historically been and continue to be, but there's some emerging things, right? Data for business insights. So this is where you start to say, hey, I'm going to collect lots and lots of data and then analyze that to get insights about my business. So think about Hadoop and MapReduce, things like that. And then data for hyperscale scenarios. So this is where we're saying, okay, we're going to deploy a business, transform the business, digital transformation application where I'm going to then service, mobile devices throughout America. Oh, let's be successful. Now I'm going to service mobile devices throughout the world, right? They are both consuming and generating data, and the data requirements for that are hyperscale, okay? So these are the data scenarios to run your business. And again, what I want to highlight here is doing a good job, being a good steward of data is critical for your business, okay? Now, for each of these scenarios, there's a set of requirements, a set of challenges that you need to address, right? You need to be able to protect that data. You need to secure it. You need to, when I say protect, make sure that it is always available, that it is durable. You need to secure it to make sure you're the only one are the only ones that are accessing it. You need to make sure that it is scalable, that it meets your business needs when your business needs it, that it is cost effective, that you have the right access patterns, that you can access the information from the right set of applications. And then I'm going to talk about hybrid integration. And the hypothesis that I have, and that I hope to prove to you here today, is that for every data scenario, for every data requirement, we're going to walk through them. I'm going to talk about how we do that on premises, and then how we do that in Azure Storage. And the assertion I have to you is, you will find that for every class of data, for every data concern, Azure Storage is by far the best bet for your company to store its data. So take that as a hypothesis, and let's see where we get to at the end of the talk. So let's drill into data protection. Okay, on premises, you need to make sure that this is durable, right? It's durable and always available. So you need to worry about, hey, what am I going to do with hardware failures? What happens when a site fails? Do I have the right people on call? Is your data always available? When something goes wrong, how long does it take before it comes up? Next, data integrity. Turns out when you store data on a disk, you have disk rot. Yeah, that really happens. And when you transfer data across a wire, guess what? Goes through NICs, goes through wires, goes through routers, lots of TORs, etc. Sometimes a 1 gets turned into a 0. Sometimes a 0 gets turned to a 1. Sometimes either one of them gets turned into something you can't really tell, so they just flip a switch. Are you dealing with that? Most APIs, most systems do not deal with that. Failover and disaster recovery. Okay, now imagine you have a real problem. What do you do in case of a disaster? Is your information eventually available, or is it available pretty quickly so you continue operations? These are things you need to address to keep your business running. And then you need to back up things and checkpoint data to make sure that it's always available, right? If something goes wrong, how do I go back, okay? So when we address some of these concerns, really I want to start our story in hardware. When we first started our Gen 1 hardware, we used traditional off-the-shelf components. Pretty quickly, we learned that that was not going to work. So using the storage components that you use in your on-premises systems were just not going to work for Azure. And so we started off an effort to build our own hardware. Starting off with Gen 1, we built new enclosures. These were higher density closures. In Gen 2, we went to 40 gigabit networking, hot swap DDs, hard drives. We had a dedicated storage backend. In Gen 3, we started to add our own FPGAs. So here we're now getting into chip design to maximize the capabilities of the storage. So we're doing things like encryption at rest and compression in hardware, adding SSD caching. If you take a look at that Gen 4 thing there, what you see is a whole bunch of M.2 SSD slots. Amazing. When it comes to Gen 5, we started to work very closely with the archive vendors to build special enclosures that are environmentally sealed, so, and leveraging RDMA. And so basically this is a story of hardware innovation. We cannot do what we need to do and what we do in Azure Storage without hardware design that I don't think anybody on premises does. Now, the good thing about that is if you want to, you could. We've taken all of our designs, and made them available through the open computing form. Now, when it comes to durability and availability, as Tad mentioned, every single write has 3 strong replicas. They first go to SSDs so that the write returns very quickly. Then that gets destaged to hard disks, and then eventually erasure coding. We use MD5 hashes on ingress and egress. So as data gets transferred, we're making sure that it gets transferred properly. And then all the data is written with the CRC checksum. So literally in the background, we're constantly reading the data, checking its checksum to check for this disk spot. And if something happens, we rewrite it because we have 2 other copies. We do disaster recovery. We have geo-redundant available storage available to you. And we have very high availability. Now, this is high availability backed by a financially backed SLA of 99.9% availability. When you have the read available GRS, geo-redundant storage, you get 99.99% availability for reads. Fantastic reliability. Now, let me give you a little hint here. So up here is the aspect that we're talking about. Down here, that's on-premises, and that's cloud. So here we're talking about data protection, the cloud. So replication options. We have the LRS, local redundant stores. Get this. 11 nines of durability. 11 nines of durability. Fantastic durability of this data. Okay? We also have GRS. So LRS, we write 3 copies. GRS, we write 3 copies, and then we write another 3 copies in another region. Okay? Now there, get this, 16 nines of durability. 16 nines of durability. So here's the thing. That basically translates into a race between data loss and the heat death of the universe. One of those is going to happen first, okay? Not sure which, okay? Now, we also have RA-GRS. What that says is the first one, the GRS, we copy the data, and then when there is a downtime, when a region goes down, we flip that over and say, okay, now this is the primary. The other copy is the primary. With read-only GRS, or read-access GRS, we make the copy available, and then you can read it. You can access that data for things like, hey, I'll do big data analytics over there. Okay, so that's available to you. And we're recently added ZRS. ZRS is Zone Redundant Storage. So when we write the 3 copies, as we do in LRS, we write them in 3 different availability zones. So basically, think of it this way. If a building burns down, you still have 2 copies. Okay? They're within the same region, but when we build out, same data center, when we build out these regions and data centers, we have separate buildings. And so what we're saying with zone redundant storage is we will store the 3 copies in different buildings. So if the building or the electricity or the cooling goes down, not an issue, you still have 2 other copies. Now, what's coming up is in the future, this switchover for GRS, say, hey, turn this to a primary, turn the other one to the primary, will enable you to make that call. And we will be building geo-redundant ZRS. So that says when you do a write, we write it to 3 separate buildings and then in return, and then we will go and copy it to another entire region and write it to 3 separate buildings there. So talk about durability. Your data is safe with us. We have backup. You can checkpoint your files and disks. The great thing about this is it's integrated right into the system. Go to the user interface, click, click, click. It's backed up. You can set policies and goals for this, right? So you can say, hey, I have to have this type of data retention. Boom, it just happens for you. And when you need a backup, again, just go to the GUI or command line, PowerShell, hoorah, click, start a backup, restore it very, very easily, right? No drama, no going to your IT department and say, hey, I'd like to do a trouble ticket. Could you do this? No, why no? Why no? Oh, no. Anyway, you just do it. We have added soft delete to our blobs, okay? So checkpointing with the blobs. So if you accidentally delete a blob, you can get it back. We have a retention period of up to a year on this, and this is now in GA. Here are the related sessions around data durability. Now, by the way, there's a tip. If you're taking pictures of the screen, that's great, but 2 things. One, whenever in fear, trouble, or doubt, run to aka.ms/Azure Storage. All things Azure Storage, aka.ms/Azure Storage. Number 2, if you are throughout the conference going to take pictures of the screen, you should be using Office Lens. It is an amazing application. It is by far, it is one of these stunning technologies. It is the best way to take a picture of a screen. Office Lens. Check it out if you don't already have it. All right. So there, talked about data protection. Again, I think you will see that when it comes to protecting your data, Azure Storage is by far the best way to protect your data. There's just no way that you can do that on premises. When it comes to data security, on premises, you need to deal with things like data theft and leak prevention. Are you really encrypting all your data at rest? Are you really making sure that people aren't putting things on thumb drives and that thumb drives is BitLockered? Okay? When you process the data, when a machine dies, a server dies, what do you do with those disks? I'll tell you what we do with those disks. We shred them. We have these amazing machines. If you ever have a chance to see one of these machines, they're amazing. You take the disks, you put them in there, and we got a lot of disks. So these are phenomenal machines. We grind those puppies up. Are you grinding up your disk drives? We do. You got to deal with network boundary, your firewalls, intrusion detection. Are you actually looking for intrusion detection, intruders in your network? Really? Let me tell you what. Remember the Target mess, right? Wouldn't it have been great, that Target disclosure, wouldn't it be great if Target had intrusion detection to find out that people had been in there stealing the data? Well, guess what? Target did have intrusion detection, and it was raising the alarm right, left, and center. But there were so many things, they just didn't pay attention to it. We pay attention to things, okay? And you have to deal with authorization, authentication, auditing, etc. Now, when it comes to data security in the cloud, we do a fantastic job. Honestly, we do. It is comprehensive. It is layered. We have multiple layers of security, defense in depth, physical access. I've visited these data centers. They are very, very, very physically secure. We have network features, security and feature security. We really do have world-class network security. We have hardware and software built and designed to protect you from DDoS attacks. We look for intruders actively, and we have a very core emphasis on the people. Look, let me just be clear on this. We hire the world's best security people, full stop. You might have some good security people, but if they're really good, they're going to end up working for us. Why? Because, no, they are. Seriously, we're on the tour to find the best security people, and we're going to pay them the most because we can amortize their skills across the widest set of assets. They're going to get to work with the world's best security people in turn and work on some of the most challenging and most rewarding challenges because they are securing the world's data. So we got the best team, full stop. Everyone that has access to anything physical or production at Microsoft has to go through a full background check. And if you want to access anything, you have to access it from a machine which is locked down, a secure admin workstation. When you access it and you need admin creds, nobody's an admin. Nobody's an admin. You get just-in-time admin credentials for just the resources you need to do. So JIT and GIA. This thing is secure. We even secure the drivers and the firmware. The firmware. We do security checks on the firmware. You might say, isn't that a little extreme? No, it isn't. Turns out there's been malware shipped in the firmware of disk drives for the last 15 years. Well, that's about 2000. For 15 years, disks were shipped with malware in the drivers. You checking the firmware of your drivers? We are. So, security and compliance. Data at rest. We've been doing this for quite some time with our keys. We now allow you to provide your keys. We have virtual firewalls. We have OAuth and RBAC for your storage. And using Azure Active Directory, your Azure files are available from both Linux and Windows VMs. We now have immutable blob storage, so you can set certain blobs to be immutable. They will not be changed or deleted, and you can define how long you want for that. And again, this applies to all tiers. One of the things I love the most about Azure Storage is the great architectural approach that they took. Look, if you go look at brochures, it might look like some of the competitors have some of these features. But when you drill into the ground reality, you're going to notice a stark difference. And the stark difference is, brand B will have feature A, and feature B, and feature B, and they're all different silos. Here, there's a coherent and comprehensive architecture. We have these tiers of storage. We have one API. Well, we have a set of APIs, but for that API, you can access storage on all the different tiers. You can decide when to move one thing to another, and you don't have to change your application. It is a coherent and comprehensive architecture. Now, lots of great information about data security. We drill into it in this session. Again, the highlight here, when it comes to data security, to make sure your company's most trusted, most important information is secure, your best bet is to do that using Azure Storage. Oh my gosh. Scalability. On premises, you need to deal with things like, how do you scale, how do you plan for scalability? What we have seen over and over and over again is that this is hard, right? It's not that your people are dopes. This is an intrinsically hard thing to do. And so what happens, and we've seen it over and over again, is people massively over-provision and have lots of unused capacity. The problem with that is that then, 6 months or a year later when they go to need to use that stuff, they're using technology that's 6 months to a year later. If they were able to buy it when they need it, they'd get the most recent technology at the best prices with the best performance. So when you buy for capacity, you're actually locking into a generation of hardware, okay? And, let me go back there. That often you have this challenge, right? You want to make sure that business success never leads to system failure, right? I remember once talking about this one very large customer, and the salesperson's like, oh, my heavens. This is a different company, by the way. It's before I worked for Microsoft, a small company. And they said, oh, it'll be a disaster if we don't get this customer. I said, my friend, the problem will start when we get that customer. We're going to have to scale so large, I'm not sure we have the capacity to do that. So you want to make sure your systems don't fail because you're being successful, okay? So cloud approach to data scalability, we are built for scale out from the ground up. Now, it's hard to get these numbers in focus. It's really hard to get in focus. So I want you all to participate in an experiment with me, okay? We're just going to count to 10, okay? So, with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you got that time interval in focus. In that 10 seconds, we just processed 500 million transactions. In 10 seconds, Azure Storage transacts 500 million transactions. We ingressed and egressed 50 terabytes of data, and we added 15 million objects. Azure Storage is built for scale. Wow. Okay, we got great capacity, and it's on tap. Use what you need when you need it. And it does not depend on hardware generation. Look, we mask that all underneath you. You get virtual hardware. You get great virtual hardware. Here's the thing. Need an extra? Use it. Turns out you don't need it, you unuse it. Imagine trying to tell your boss, yeah, I bought this huge storage area network array. Turns out we don't need it. Good deal, huh? No, not a good deal. That's a tough conversation. Not here with us. Now, here's the point that really I got in focus recently, and it was the notion that when we started off doing the cloud, I think everyone assumed that the model would be a bunch of sort of the RAID model, right? Redundant array of inexpensive disks, that we're going to take inexpensive, kind of cheap components and then use software to build things on top. And that was sort of the model. You'd rewrite your applications for the cloud, right? Well, reality's turned out a little different. Reality is that we are now providing not an environment where you have to rewrite your applications. You can leave your applications alone, move them to the cloud, and we're delivering you Tier 1 hardware. Tier 1 hardware. We got the best IOPS. We got the best durability. We have the best scalability. This is Tier 1 hardware that you do not have to change your applications to run. So, Yamin, come on up and show us a great example. And which one are you? 6?
So, hi everyone, I'm Yueming. Previously, we have talked to many of you. You provided us feedback that you need larger scalability on this capacity. There are two common scenarios to this. One is that if you're running a data-intensive workload, for example, a database backup server or a file server, where you need tons of storage but not that much memory and compute. In this case, you will need a solution where you can scale your storage independent of your compute. Another use case is for disaster recovery. If you have machines which are on-premises and you want it to fail over to the cloud, you do need a disk on Azure, which is big enough for you to fit all the data on one single drive from on-premises. Today, we're proud to announce our preview of larger disk sizes supporting up to 32 terabytes. It's going to be supported. I'll give you some time to clap. I know this is one of the most wanted features. So for larger disks, it is supported on premium SSD, standard SSD, and also standard HDD. It is significantly larger than any HDD and SSDs you have on premises. So let me show you in a real VM setup. So here, I have a D1 VM. So this is one of the smallest SKU from the general purpose use very popular VM family. On this VM, I can create a 64 terabyte volume out of two 32 terabyte striping across two 32 terabyte disks. So even with one of the smallest VMs on Azure, which costs you only around $50 per month, you can get storage up to 64 terabytes. Let's also take a look on the larger side. So here I have a DS14 VM, still one of the very commonly used size, but slightly more on the higher end. You can attach 64 disks. So you have 64 32 terabyte disks attached to this single VM. So effectively, you have 2 petabytes of data. So yes,
is that crazy?
I would really wanted to present you a 2 petabyte drive, but due to NTFS limitation, I need to show you 8 256 terabyte. But just to give you context regarding of how much data 2 petabyte is, this is data box heavy. You need 2 of these to actually fill in the data that you can attach on one single Azure VM. If you happen to know why this guy is not here, it's around 500 pounds. So that's how much 2 petabytes of data it weighs. So for large disks, it is now preview in West Central US. We expect it to GA by end of this year in all Azure regions. Thank you.
Wow, thanks so much.
Thanks.
That's fantastic. So that's a great illustration of what I mean by tier 1 hardware. Okay, now we're going to go fast. Disk scalability. You use standard hard drives, standard SSDs, standard premiums. Great stuff. Guess what? Put your belts on. 8x performance, 8x increase in size. IOPS go from 3 to 8x. Now, these do not require, you just get these improvements. No extra cost. How's that for a good deal? Is that crazy? And we've added the Ultra SSDs, right? Fantastic performance, right? Fantastic latency, incredible IOPS, fantastic bandwidth. Now, in terms of Azure Files, great feature. Boy, it just takes it to another level here. We now have 10x, 8 to 10x the number of IOPS and bandwidth. So now Azure Files goes from 5 terabyte stores to 100 terabyte, and the IOPS, look what happens there. But then, wait for it, premium files, 100,000 IOPS, 5 gigabytes of bandwidth, and 100 terabytes again. Amazing stuff. So that's 80 to 100 times performance increase. Just fantastic stuff. Now, Klaus, come up and show us a wonderful stuff here.
All right.
What number are you on? You 8?
So, I'm here.
Oh, sorry. Yes.
So I hope you're as excited for performance as I am. I'll show you a demo around blob write performance. Why is blob write performance interesting? Well, you get one of these, you get to offload its data into an Azure data center. You want to make sure that it gets into Azure as quickly as possible. You have your analytics workload running ADLS Gen 2. Guess what? We've got blobs behind it. Write performance, super important to get the results written out fast. You got a simulation going on for autonomous driving. Massive amount of data that gets written out into Azure Blob Storage. So let's orient ourselves first in this demo. So if you look at this in the upper left corner, you got Azure Storage Explorer pointing towards the storage account that we're running. Below it, we have our workload generator, or actually we have the orchestrator of our workload generator that's going to drive 4 D64 VMs doing writes into Azure Blob Storage. And on the rightmost window, we have good old perfmon from Windows Server showing the total bytes per second for each of these 4 D64 VMs. All right? So the first step is we're going to go in and see what we have in our storage account. So let's refresh. There's absolutely nothing. Right? And then we're going to start our workload orchestrator here. So what we're doing is we're moving 50,000 32 megabyte blobs into Azure Storage using 4 worker VMs. So now they're all spinning up and doing throughput. And you can see each of them is sending about 35 gigabytes 64 on the network, B64 on the network, B64 on the network. Let's go ahead and speed time up a little bit so we can see the results. And now they're done. They're spinning down, reporting back to the orchestrator. They've completed. So let's zoom in and see what we saw. So we just completed this test in 119.7 seconds. So we wrote 1.5 terabytes of storage into Azure in a single blob, one blob, in 2 minutes. That is at 110 gigabits per second, or 12.5 gigabytes a second.
I think that deserves a round of applause. That's just crazy.
Thank you. And let's see that it's actually there.
Yeah, that's a good point.
Right? So let's refresh. Yes, we have a container named container.
Yay.
And we have a blob named blob. Very innovative names, I know. And here it is, 1.5 terabyte object in 2 minutes.
Wow.
So what you saw was high throughput blob, which we can ingest blobs with high throughput. But what you may not have noticed was that it was instantaneous. The throughput just burst. There was no need for wait for warm up or anything like that. It was just instantaneous throughput. What you didn't see in the demo was that we don't care what the names are in terms of container naming and blob names. So if you have these long names with just the tail being different, it doesn't affect throughput performance here. Let's switch gears and talk about premium blobs, which is in preview. So premium blobs, so what you're looking at here is essentially the same application in two windows. One of them is pointed towards a standard storage account that we have had around for a long time. And the other one is pointed towards our new premium blob storage account. So what I'm doing is I have a population of 1,064 kilobyte objects in each of these storage accounts. I'm going to read 1,000 random objects one by one to illustrate the effects of latency from premium storage, or actually the lack of latency. Right, so let's get them started. I'm going to start on the left and get that going, and I'm going to go to the right. And you be the judge which one you want to buy.
One of these things is not like the other.
That's right. The one on the right, we even print out the results here, 5 milliseconds on average, and very, very stable consistency. And then let's fast forward to get the other guy a chance to finish up. And we see how that behaves.
Wow.
So that is premium blob storage, which is in preview. Right? Low, consistent latency, supported for block blobs, append blobs, consistent API, the same API you use today, just pointed towards a premium storage. It's available local redundant storage.
Fantastic. Thanks so much.
Thanks.
Cheers. So we have massive improvements in blob scalability, right? We have over 40x objects transactions per second for high throughput blobs, and over 200x per object writes in high throughput blobs. And then our premium blobs have single-digit millisecond latency. Just phenomenal, best-in-class stuff. Here's a bunch of great sessions. Again, the key thing is that's the URL to get the details. Now, cost effectiveness. We're cheap. Here's the key thing. Where are we going to go? Right here. Hey, many of you have petabytes going to exabytes. We have exabytes. We are going to zettabytes. Okay? I mentioned to you a bunch of hardware innovation, doing our own hardware design. What has that done? This is a chart showing you our dollars per gigabyte. Okay? And what that translates to is between 2010 and 2018, we have reduced the cost of storage by 98%. Boom. Craziness. And that will continue. By the way, just get this in focus. Let's get this in focus. You, as an individual, go to Fry's and buy a disk. How much is that going to cost you? A lot of money. Now, as a company, you're going to buy 100 of those things. You're going to get a discount, right? And if you get 1,000, maybe you get a bigger discount. Think of the discount we get, because we're buying millions of these a year. I will tell you, none of you can buy disks at the price we buy disks. And we pass on that savings to you. Now, we're also working on advancing the state of the art. We're storing data in glass. We're working with researchers to get to technology so that we can store data in glass. The great thing about these, using these amazing femtosecond lasers, is that when it's written, it lasts for millions of years, right? No bit rot. We are also working with DNA, again, advancing the art, being able to store data in DNA, right? So DNA, if you're not familiar, it's 4 things, A, G, C, T, and G. So we have zeros and ones, they have these. We're able to do a transcode of that, store information in data. By the way, this sounds a little science fiction-y, but in reality, there's a whole biotech industry developing this technology, and we're drafting behind them, saying, hey, given that you've done that, we can use it for this. So this is absolutely gonna happen. See that little dot there? That little dot there contains 10 terabytes of data. By the way, we're doing this today. I mean, in the labs, but this is actually happening today. Now, with our Azure tier blobs, the premium blobs, 2 things to note here. So one, we got tiers for Azure Blob. We have our archive storage, half the cost of the competitors. Half the cost of the competitors. In terms of transactions for our premiums, again, super low cost for the transactions on our premium storage, our premium blobs. When you manage these things, again, you don't have different hierarchies, you don't have different APIs. You have one set of things. You say, I'd like that blob to be this tier or that tier, hot, cold, archive. That happens for you. You can set up policies to move your least used data from one tier to another. For archive, this is available in 8 new regions that we're announcing here. Lots of great information on cost effectiveness. So again, when it comes to cost effectiveness, Azure Storage is by far going to be the best way for you to store and be cost effective for your company's information. When it comes to access patterns on premises, you basically are picking which access. You got storage, you got access protocols, right? And here we're talking about NFS, SMB, etc. And then, well, what about other things like Hadoop, right? Can you access the same information through different protocols? And often the answer is no. And the problem with that is then you end up with data silos. And then either the information is only available to one access pattern, or you have the issue of migration of data. When you migrate data, then you have problems of different sets of data, different data protection, etc. It's a real problem, and it's one of the great benefits of our coherent architectural approach. We allow you to take multiple access patterns and access the same storage. Okay? So this gives you simplified data management. You set the ACL once, it's coherent across different access patterns. So concretely, you can use HDFS. This is the Azure Data Lake Storage Generation 2. It is an API and protocol on top of the same storage that you can also access via Blob APIs. Now, we hear a lot about new architectures like serverless computing. This is basically how serverless computing works. There's some sort of a trigger event, goes to an event router, and then there's serverless runtime. Now, as your enterprises adopt this, you're going to find that Azure and Azure Storage is one of the best places to do it, because it turns out that most of those events really are storage events, right? Blob storage events. Somebody puts something in Blob, a security camera, puts something in a Blob storage, then you get the event from that, you analyze it. One of the great things about our event hub, it is a multiplexed event hub. It will span out to multiple providers, be it logic, apps, or functions. Competitors don't do that. They have single consumer supplier model. So you find that Azure Storage is one of the Azure Storage, Event Hub combined are one of the best places for you to implement your new modern architectures. Very hard to do this on premises. You can, but basically you end up doing all the systems integration, and good luck with that. You know, you want to make sure you got your rabbit's foot in your pocket, because you're going to need it. That's really hard stuff to do. Again, related sessions. think we have time. We have this, we talked about a VR. Great stuff. Hybrid file sync. We got to get to the demo. Here's the point. Hybrid file sync, amazing functionality. If you do not have this in focus, you definitely want to. There's a file server available on premises, does its traditional file server thing, right? Provides work folders, provides SMB, NFS access to people. With file sync, it now gets replicated up to the cloud. You get cloud tiering, you get multi-cloud, you get cloud access, you can access from the cloud, and we will sync it to other sites. So you can think of this as DFS ***+++, much better. The great thing is, again, you got cloud backup. If a server goes down, you have fantastic disaster recovery. Let's get a demo of that. Fabian,
thank you so much.
Show us.
Thank you. All right. So we're on this one here?
Yep.
All right. So let me show you real quick what fast disaster recovery with Azure File Sync really means and how really usable it is for one of your information workers to access a freshly recovered server. So let's keep going here. We are on our Azure portal, and I'm showing you a sync group that designates the synchronization of a set of files. So we have one cloud endpoint and a server endpoint in here. Let's look at the cloud endpoint. That's really pointing to an Azure file share. And we can go to the storage account, look at our file share. It's called Project X. And we have a set of files in there that is already syncing with the server that we're looking at here. So these two are fully in sync. And now let's swing over to another server. I stood this server up because we just had a recent disaster. Something burned down or I lost my entire storage. I needed to stand up a brand new server that has none of my data on it. So all I did was I installed the Azure File Sync agent on the server, and I connected it and basically built a trust relationship with my storage sync resource in the cloud. That's all I had to do. So now let's go to the Azure portal here as well. And let's take a quick look at the registered servers here. So that was the trust relationship creation that I mentioned. It's the server on the bottom. So it's the second server that we're trusting. So let's go back to our sync group. We only have one, which is our Project X sync group. And we want to add that server to the sync group so we can recover the same data onto that server. So all I have to do to begin with is I'll designate a space on the server where I want to sync my data to. So I go to the E drive here. I'm going to go and add a directory. I can call this whatever I like. I can call this Project X, or I could even sync to the root of a directory. It doesn't really matter where you're syncing it to. And then all we have to do in the Azure portal now, because we're already trusting the server, so this is cloud management in itself. All I have to do is I go to add a new server endpoint. The only server endpoint I can add here is the server that we don't already use, so that's the recovery server. I simply tell it where I want to sync my data to. I say cloud tiering on. I say 20% free space. I don't have to use cloud tiering here. Fast disaster recovery works the same way every time. So now I go to my server location, and as this is provisioning, this is happening really, really quickly in the background. So even before the portal shows it, we're going to see the whole namespace popping up into my share or into my folder on the server. So the interesting thing here is we can do this so quickly because we separate the file content from the namespace representation. We just get the download of the namespace representation. At that point, the users and applications can already start accessing a file. And if you don't believe me, let's have a look what that looks like. So there is a bunch of video files in here. And what I can do is let's pick one of the bigger ones. Maybe let's say this 140 megabyte file. I just want to play that video file right now. So this file is not on the disk at all. And I haven't played on the server before. So let's get that going. And for applications that support partial file access, and these are applications like, think of zip archives or think of media files. There are many other examples for this. We support partial file recall in the background. See that little screen indicator on the bottom left corner?
Right to the PowerShell. Good stuff.
Right to the PowerShell. So, and it's recalling just in time what that application actually requests. So So we're not recalling any other data that is not necessary. And at the same time, the user doesn't have to wait until the entire file has come down for it to be usable.
Fantastic.
So let's have a look at what that actually looks like in the, can I see this? No. So if we were able to see this here, what you would see in the properties is you have a logical size of about 140 megabytes. And what you see as the size on disk is now a couple of megabytes that I downloaded just because this is what the player application requested me to download for the customer here.
Wow, that's fantastic.
Thank you so much.
Thank you. All right. So, again, these are the scenarios that you need to manage for your business, these types of scenarios. And these are the concerns. And hopefully you see that, agree with my hypothesis that for each one of these scenarios, for each one of these concerns, Azure Storage is by far your company's best bet to address these concerns for those scenarios. Have a great Ignite. We got lots of great information. Again, aka.ms/Azure Storage for all the information that's going on at Ignite. We got a great booth with people. Oh, and here is that. And we've got a reception. So we got a reception. A bunch of the team will be there. We got tickets here. Come up, grab a ticket. I think, is it going to be beer? Yes. It's going to be beer. Okay. Thank you so much.